Dear students, today I'll discuss with you some important MCQ from the chapter Atomic Structure. The first question is uncertainty in position of an electron whose mass is given moving with a velocity of 3 multiplied 10 to the 4 cm per second accurate up to 0.001 percentage will be what? Okay, so we'll do first question. Number 1. So 0.001 percentage of velocity. Okay. So find out velocity delta V. You will to find the velocity 3 multiplied 10 to the power 4. It's 0.001 percentage. Okay. So it is given in cm per second and you can do it into the meter. So okay, so this you will get like this. Okay, so or you can take simply it is in cm. Okay, then its value you have to put in the uncertainty principle. So delta x multiplied delta v is equal to h by 4 pi. Okay, multiplied mass, because mass into velocity is equal to momentum, change of momentum. So you put mass value is given, so delta x you will find h by 4 pi 3.14 multiplied 9.1 mass 10 to the minus 28 gram. Then your velocity 3 multiplied 10 to the 4 0.001 divided 100. Okay, so you will get the answer by solving all these, and you put also h value. So h value is 6.6 multiplied 10 to the power minus 34. It is also given. Okay, so by putting all this you will get the value 1.93 cm. So choice C is the correct answer. Okay, next question number 2. The radius of helium. Question number 2. The radius of hydrogen atom in the ground state is 0.53 angstrom. The radius of lithium 2 plus ion in a similar state is what? Okay, so it is asked the question number 2. So how to do? You see, radius r0 multiplied n square by z, and this is orbit and this is your atomic number. Okay, so you put 0.53 multiplied n square by 3. Okay, so for lithium it is 3. So by solving you will get the answer 0.17 angstrom. You will get. Okay, so choice C is the correct answer. Next, in a Bohr's model of an atom, when an electron jumps from n is equal to 1 to n equal to 3, how much energy will be emitted or absorbed? So generally from lowest to highest state, if it jump, then it have to absorb energy. But how much you have to calculate. Okay, so question number 3. We know the R value, Rydberg constant value, minus 2.179 10 to the power minus 18 joule, or in erg it is minus 2.179 10 to the minus 11 erg. Okay, so En energy minus RH by n square. Okay, so your E1 is equal to minus 2.179 multiplied 10 to the minus 11 erg. E3 is your minus 2.179 multiplied 10 by 9 to 10 to the minus 11 arc. Okay, so delta E is asked, so E3 minus E1. Okay, so common is your minus 2.179 is the common, and 10 to the minus 11 is also the common. Okay, so you will get your minus 1.9 plus 1. Okay, so minus 2.179 10 to the minus 11 multiplied 8 by 9. Okay, so answer you will get 0.1936 multiplied 10 arc. Okay, so choice 3 is the D. It is your choice, correct answer. Okay, students. Next, in Bohr's orbit, radius for hydrogen atom n is equal to 1 is approximately this much. The radius for the first exit state orbit in angstrom is what? Okay, question number 4. Same question, Rn is equal to R0 multiplied n square by z 0.530 multiplied 4 divided 1. Exit state, it is 2 square. Okay, it is 2 square 4 you will get. So you will get how much? 2.12 angstrom. So choice D is the correct answer. Okay, next, the position of both an electron and helium atom is known within 1 nanometer. Further, the momentum of the electron is known within 5 multiple 10 to minus 26 kg meter per second inverse. The minimum uncertainty in the measurement of the momentum of the helium atom is what? Okay, so question number 5. You see, delta x, okay, delta x electron uncertain momentum, position is equal to h by 4 pi delta p of electron. Okay, but delta x of electron is equal to delta x of helium also, which is given 1.0 nanometer. Okay, yes, and we know delta x of helium multiplied delta p of helium is equal to also h by 4 pi. Okay, so therefore delta x of helium is equal to h by 4 pi delta p helium. So both are same, therefore h by 4 pi delta p of electron is equal to h by 4 pi delta p of helium. Okay, so therefore what is the value given here? What is the value given here? It is for electron, so for helium also it will be same. So you will get choice D is the correct answer. 5 multiplied 10 to the minus 26 kg meter per second inverse. Okay, students. Next question. Question number 6. When modified Bohr's theory, who modified Bohr's theory by introducing elliptical orbits for electron path? Okay, so question number 6. The elliptical path like this: first cell, then the second cell, then it is the third. So these are elliptical going on. Okay, this is first, second, third. So we know n by k. N is length of major axis, length of major axis. It is length of minor axis. Okay, so number of elliptical path, number of elliptical path, okay, by r orbit in a cell is equal to n minus 1, where n is the principal quantum number. So here D, Sommerfeld. Who is the Sommerfeld? Next, the frequency of radiation emitted when an electron falls from n4 to n is equal to 1 in a hydrogen atom will be given. Ionization energy this much and Planck's constant is given. So you have to find the frequency of radiation. Question number 7. Okay, how to do? New frequency, you see, frequency is equal to c by lambda, velocity by wavelength. But 1 by lambda, we know it is related to Rydberg constant, and the relation 1 by n1 square minus n12 square into atomic number square. Okay, so then c value nu is equal to c r 1 by n1 square, 1 by 1 fourth, this is fourth, so this is your 16, and z atomic number, it is 1. Okay, so then c r, this is 15 by 16. Okay, so you put all these values. C value 3 multiplied 10 to the power 10, R value 109,678 multiplied 15 by 16. Okay, then you will get what? 3 point, the answer is 3.08469 10 to the power 5. So choice C is the correct answer. Okay students, next, number of spectral lines falling in Balmer series when electrons are de-excited from nth cell will be given as what? So you have to remember this n-2 in visible region, Balmer series n-2 in visible region. Okay, next, the question number 9, the ratio of the energy required to remove an electron from the first 3 Bohr's orbit of hydrogen is what? So question number 9, you do first 3. Okay, so you know energy En is equal to minus 1312 by n square. Okay, and you say this is your y and this is your x. Okay, so this is x square or n square. So you, for energy E1 you will get y minus y by x square, 1 square. E2 is equal to minus y by what? 2 square, that is 4, minus y by 4. For E3 minus y by 9. Okay, then it is ratio E1 is to E2 is to E3. You will get what? You will get E1 is to E2 is to E3. Okay, so what is E1? E1 is 1 by 1 is to 1 by 4. this is 1 by 9. So the common LCM is what? LCM you will get 36. So 31 by 36. Okay, so this will be 36. 1 is the 36. Then this will by 1. Okay, then this is your what? This is your 9 and this is your 4. So 36, 9, 4. 36, 9, 4. So choice C is the correct answer. Okay, students.